Okay, I might be back. Um, okay, I think I'm 720p now, so that hopefully is better. It looks better in my preview, so hopefully that's good for everyone. Okay, so I'm going to go ahead and proceed. I think if there is a lag that's maybe not as bad as blurriness, because blurriness you can't see what I'm talking about, but if there's a lag, you just have to wait a couple seconds, and really you don't have to watch me talking. I'm just here to kind of provide a sense of presence. So hopefully that's okay. Okay, great. So yeah, well, hopefully we'll continue with this and it'll be good. All right, so I'm going to go into the tutorial, and if you have questions about the stream itself, put that in the Twitch chat. If you have questions about the tutorial, try to put it in the Discord chat so that I can try to answer there. And I see both of those, so either one should be fine. Okay, so this is the notebook that I started the other day, and I started building it kind of with some structure that worked for me, that made sense, but though that was a different kind of structure than what the tutorial describes. I'm going to take out this word first because I'm not so sure that that's really first. It's just what I was doing here in the next cell. And if you remember correctly, if you remember what I did before is I've organized it so that all my importing and any libraries, like things that I might need, I'm going to try to do in this cell. I'll go ahead and run this one to start the runtime. And then in the next cell down here, I'm putting any general purpose functions and settings. And what I'm doing here essentially replaces the need for what the tutorial does with obo.py. So they create, as they go, they build a library as they go, and they call it obo.py. But in this case, it's just a cell, and I'm going to put the functions there when I need them. So let's see. It looks like I'm connected. Looks like I'm running a runtime, and it already went ahead and mounted my drive, so great, because I will need that. And so these are the functions that we created last time. So it's get engrams and strip non-alpha num, and those are pretty descriptive titles or names for those functions. So getting engram is going to return a list of engrams, and stripping non-alpha num is going to strip all of the punctuation marks and anything else like that out of the text, and then return it just as a bunch of lowercase letters. So, or as a bunch of letters, and then we also did a lower down here. So this is where I was actually using it. I've written it here so I'm getting a whole bunch of files from my Chesterton folder. I got a bunch of files by GK Chesterton, and those are all in here, and they're just now loaded here into this list called files. And in this case, I'm just using one of them, the file for The Man Who Was Thursday, and doing this thing on it. I open it and read it. It creates that or transforms it into a word list, and then this right here is going to call the get engrams function and return the result of that into this value called thursgrams. And it's in this variable called thursgrams. This is now a long list of 5 grams. 5 because that's how many I asked for when I ran the engrams function. Engrams can be any length, but in this case, I asked for 5 grams. So there's a lot of them, as I found out, and so this is the 40,000th and 40,000 and first engram. And if I ask for the next one, I should see how there's a sequence here. So this one is the man whom he had, and then this one should be man whom he had come. So those are both 5 grams. Okay. So what can we do with engrams? That's a good question. So we have, I just asked myself that, and then I told myself that was a good question. You may be wondering, what can you do with engrams? If you are, that's a good question, because we can do that programmatically. This wasn't super complicated in terms of what Python is doing, but understanding what we would want to do with it, that's the really interesting and challenging part for us. We did find a few studies back when we gathered that list of case studies that were using engrams, and we'd have to look at how they're doing it specifically. But one thing we can think about with engrams is think about characteristic phrases or turns of speech or just even certain groupings of words that people tend to use when they write. And so if we can identify tendencies, we can identify or generalize about style, and then we can start to compare different styles. And I think that's what a lot of you are trying to do. So hopefully we'll get something here that will work with that. Ultimately, though, I think as we complete this tutorial, the next one, the outputting keywords in context, essentially we're going to get what's a concordance view of any engram. We will be able to see any engram or any word in a context, and that will be useful to analyze a specific text. We'll have to do a bit more or create some other structure to actually compare engrams between things, but that's where we can get to next. Okay, so if you have questions again, put them in here. Also, if you have requests, put them in here. But otherwise, let's proceed. So this is, where are we? Here we are. This is the lesson from Programming Historian, as they say that you need obo.py, but we don't because we've already done it. This says this builds on the keywords and context lesson, which is what we did last time, so we're moving on. And what we're going to be doing next is making an n-gram dictionary. So this is how we're going to do it. Let's see. It's talking about a dictionary here. A dictionary is a specific type of Python data structure, and the other kinds we already know about are strings and lists and integers, floats. These are the types of things. A dictionary is a specific kind of structure, and it's a way of saying this is the context for that thing in this case. So we're going to be creating, it looks like, a dictionary where, for example, the keyword best has as its 7-gram this list of words that are immediately before and after it. And I guess that's why they're saying they need to do an odd number, because that makes it a bit more intuitive to understand that there's the same number on both sides of this one in the middle. Alexandra, no, that's not what that is. And that's a kind of question for Discord maybe, but it's not the 5 most common words. The 5 most common words, the 5-gram, a 5-gram is 5 words that appear next to each other in that. And so each text is going to generate several 100,000 n-grams or 5 grams. So, Allison, if the stream is cutting out, then it may, hopefully it's archiving it okay and you can watch it later. Or if you miss something, then like if something cuts out and then I keep moving on that you don't understand, then definitely ask about a specific thing. So in this case, so Alexander, to see it, like it was the best of times if we look at the word, if we're interested in the word best, this is the 7-gram that it is located in this case. And there will be other 7 grams in which the word best is located, but this one is one of them for that source text. Okay, so in that sense, every word that appears in a text is going to have an n-gram context. And to do that, I guess we're going to be creating a dictionary of all those contexts where there's an entry, like a value of a name, and then as the I guess the value of that entry, it's going to be a list of lists. So let's say, what does this number 1 mean? If we are working with 5 grams, for example, the left context will consist of terms indexed by 0, 1, and the keyword be indexed by 2, and the right context terms indexed by 3. Okay, yeah, that makes sense. Okay, so this is an interesting idea, and I'd never seen this before. Apparently you can do floor division in Python. I think I showed you all that you can do, like there's some weird issues with math in Python. So if you were to do just 7 divided by 2, you are in Python 3 going to get 3.5, but in Python 2 you're going to get 3.30, like just 3 with no decimal because of the difference between integer math and float math. That difference is not present in Python 3, so we don't have to worry about that as much. But what they have here is a situation where we actually don't want 3.5. We want to be only working with whole numbers because we're going to need these as indexes to access a particular list position. And if we're looking at numbers as a position in a list, like it is at position 0, was is at position 1, the is at position 2, there is no position 1.5. There's no decimals. That doesn't make sense. So we definitely always need integers, and we need to get the right one. And so apparently this little shortcut here of doing the 2 division signs or 2 forward slashes apparently will force it to be the integer. So that's kind of nice. There's probably, I mean, we could also write that differently. We don't have to, obviously, but this would probably this should give you the same answer. This is just saying do the math however you feel like as a float or an integer, but whatever when you're done with that, then transform that into an integer. So it's going to essentially round it down to the lowest, to the next integer below it. I think that's what's happening there, and I don't know. I don't know if there's a real advantage to those 2 different ways of dividing 7 by 2, except that the 2 forward slashes is a bit shorter to write and a bit more elegant. So maybe that's better. So we'll go with that. And that's a good concept. Let's move on. All right. So this is a function that's going to identify the index position of the keyword when given an n-gram with an odd number of words, saving the following to obo.py. Okay. So this is a function. It expects n-grams as the argument, and it's going to tell us where in that list our keyword is. So interesting. Okay. So I'm going to add this to my general purpose area up here and then try to play with this a little bit. So I haven't modified their code at all. I just copied it in here. It's this function named ngrams to quickdict, and quick stands for keywords in context. So we have thousgrams here. This right here, thousgrams 40,001. That's a specific n-gram. That's a specific 5-gram. So let's try this. Test gram equals that one, and then I want to know which of those is the keyword, or the middle word. And so that function here, ngrams to quickdict, is supposed to tell me that, I think. So let's find out. Just print ngrams to quickdict. Give me a 1. Is that what I wanted it to give me? I don't know. I'm not sure what that 1 means in this situation. Oh, I see. Okay, because it's expecting us to have a thing called ngrams and then use the first. Okay, so that's what's different. So what I pass to it shouldn't be specific to a single 5-gram, but to my whole n-gram database. So I don't need to give it test gram. I need to give it thousgrams because that's my thing. Yeah, that's better. That's what I wanted. So this is telling me that the index position of the keyword is going to be at 2. In other words, 2 is going to be the middle of each of these 5 grams. And